I want to welcome everyone to my lecture today. Today, October 16, I'm actually going to be walking you through another exciting topic in statistics called Hierarchical Multi-Level Logistic Regression Model. You remember last time we actually did random effect model in linear regression model. Today, we're actually going to be extending random effects to logistic regression model. Okay, so the outline is actually going to be mixed effects in logistic regression, and the implementation of that will be done in our last lecture. I think I actually implement that using the Python software, but the focus today is going to be on R. Okay, so let me first explain the mixed effects in logistical regression. Now, the mixed effect in logistical regression is just, the statistical model that actually combine both the fixed effect and the random effect. When you take a look at the conventional logistic regression model, what do we actually want to achieve? Of course, we have a response variable that is categorical, and a a certain number of predictors. Okay, and of course, in a situation whereby we are trying to look at the effect of one or more predictor on a categorical response, of course, we normally use logistic regression model in such a way that all the predictors are actually assumed to be fixed. Okay, but we got some situation whereby we actually also need to incorporate a random effect into the model. In the last lecture, of course, I demonstrated the need for incorporating random effect into a linear regression model. And of course, when the assumptions of independence is no longer guaranteed, of course, we got no choice than to incorporate, random effect into a model. Okay. So, and of course, I think I give you an example the other time. We got a situation whereby we actually want to study, student performance in certain subjects, and we realize that the students are nested in schools, and schools are nested in school districts. Of course, because there's also going to, apart from having a student variable, we're also going to have, school variables. Okay, so because of that, there's need to incorporate random effects into that model. Okay, and another example I gave the other time, I actually talk about situations whereby some group of some patients are being seen by doctors. Okay, where doctors now become like a group. We are, of course, the patients in that particular group seen by the same doctor, their response are not likely to be independent. Okay, and that is the reason why we actually need to incorporate a random effect model that will take account into the doctor variable, okay, and stuff like that. Okay, because we expect doctor to have different kind of experience, and so on like that. So now, if the response variable, in an attempt to look for, to try to investigate, how certain selected predictors actually affect the response, and the response that we're talking about is dichotomous in nature, is binary in nature. Of course, we got to look beyond conventional logistic regression model. Okay, we need to look for a logistic regression model that can actually incorporate a random effect. Okay, so because of that, I'm actually going to define the mixed effect logistic regression, is actually used to model binary outcome variable, okay, in which the log odds of the outcomes are modeled, of course, as a linear combination of the predictor variable when data are clustered, okay. What do I mean by data cluster? Is just like, okay, cluster that, a patient clustered around doctor, okay, in a situation whereby a particular doctor is seeing a lot of, a group of patients, of course, then we're trying to say the patient are being clustered around that doctor, okay? Or in a situation where we're talking about a student clustered around a classroom, okay? Of course, different classroom, we got, students, in them, the classrooms are bigger than students. And of course, the classroom are nested in school, okay? So, in my last lecture, I actually talk about different hierarchical levels, okay? And of course, in any hierarchical data structure, you need to first identify the atomic unit, okay? Atomic unit is just the smallest unit of, you're going to be of, the smallest units of measurement in the hierarchical structure. So in the case of a patient, doctor, and clinic, of course, the smallest unit is actually going to be patient. In the case of a student nested in classroom nested in school, of course, we're going to be talking about, the students, okay? So because the the response is actually going to be obtained from the smallest unit in the hierarchical structure. Okay, now if we want to do this now, okay, if you want to actually implement, to estimate parameters in the hierarchical logistic regression model in R, of course, we actually need to load the packages that I'm actually projecting right now. Got to load the ggplot, the ggallic, the reshape tool, the LME4, compiler, parallel boot, and lattice. Okay, they actually need to be loaded before we can actually, estimate parameters from the logistic regression model, where the random effect is being incorporated. Okay, so before I move into the analysis, using R, I think I need to for give you some example, of hierarchical or random effect logistic regression model. Number one example is a researcher sample application to 40 different colleges to study factors that predict admittance into college. Okay, admittance into college, when you apply into university, of course, it's either you were given admission or not. Okay, so the response here is categorical. Okay, so is dichotomous in nature, is binary. Okay, so that you are given the admission or not. Of course, um, if before you can be given admission, of course, the university, the colleges have to make sure they study certain factors. Okay. Now the predictors include the student high school GPA, extracurriculum activity, and SAT score. Okay. Now, some schools are more or less selective. Okay. Now, take a look at this statement. Some schools are more or less selective. So the baseline probability of admittance into each of the school is different. Okay. Now, because of that statement, of course, you actually need, I think I'm going to underline the statement right now. Because of this statement right here, of course, you actually need a random effect. Okay. And which means there's going to be school level predictors. And the school level predictor will include whether the school is a public or private. Okay. Then the current student to teacher ratio and the school rank. Okay. So all these are more or less like the school variables. Okay. And of course, we got to make sure, the random effect is being incorporated, to be able to account for that. Okay. So, the next thing I'm actually want to talk about, going to the next example right now. And of course, this next example is, what we're going to focus on, using the R. Okay, a large HMO wants to know what patient and physician factors are most related to whether a patient lung cancer goes into remission after treatment as part of a larger study of treatment outcome and quality of life in patients with lung cancer. Now, let me tell you this. You know, in an attempt to investigate factors that can make a lung cancer to go into remission. Now, what do we actually mean by remission? Of course, remission can actually be divided into partial remission or complete remission. When I say partial remission, I mean it's like you know the tumor size has actually been reduced to certain size after medical intervention. Okay, so which means though we still have some cells, cancerous cell, but they've been able to subdue, or they've been able to minimize that to a certain degree of size. Okay, and if I talk about complete remission, then of course I'm trying to say that the patient does not really show any sign of of the disease anymore. Okay, that's a complete remission. Okay, maybe after undergoing a medical operation, and and by the time they scan, they actually carry out image processing. I mean, by the time they by making use of the scan, they realize they were not able to see any trace of that anymore. But we got to be careful right here, because we could have situation whereby they could hide and they could reoccur or later. Okay, some and another and the activity of human being could make them to reoccur. Okay, but what we are trying to study right now is just okay, what are the patient and physician factors that are more likely related to whether a patient lung cancer goes into remission or not. Okay, and of course right here the response variable is actually going to be categorical. Okay, now another example right now, uh, is going into social life. Television station want to know how time and advertising campaign affair whether people view a television show. Okay, they sample people from 4 city. Okay, for 6 months. Okay, each month they ask whether the people had watched a particular show or not in the past week. Okay, and after 3 months they introduce a new advertising campaign in 2 of the 4 city and continue monitoring whether or not people had watched the show. Now when you take a look at this situation, of course there's a trace of a repeated response. Because what do I mean by a repeated response? Okay, there's with that situation whereby certain group of respondents would have been interviewed more than once, and of course the response from such respondent may no longer be independent. Okay, so there's actually going to be a violation. The bottom line here is that there's going to be a violation of independence assumption, and that was the reason why using the conventional logistic regression model that actually assume that independence assumption hold, we no longer be appropriate, and that is the reason why we actually need to incorporate a random effect into the model to be able to capture that data structure. Okay, so the next thing I want to go into right now, like I said, the other time I was talking about, the example two. If you take a look at the example two that I projected, the other time, I said we want to look at the effect of, patient variable and patient factors and the doctor's factors on the remission of a lung cancer. Okay, and because of that, in order to incorporate, in order to be able to address, okay, what could be, to withstand the hierarchical nature of the data. Of course, we're actually going to incorporate what we call random effect. Okay, now take a look at it. The IIC, the CRP, and the length of stay. Okay, we see that as patient level continuous predictors. Okay. Then the cancer stage as a patient level categorical predictor, of course, they're going to be the cancer stage going to have, level 1, level 2, level 3, or level 4. Okay. Now, the experience of a doctor now, is also going to be put into consideration. Okay, that was what I said. Experience as a doctor level continuous, that's a continuous predictor. Okay, and of course, and a random intercept by DID, which is the doctor ID. So, which means here we're actually going to be using a random intercept. Now, let me tell you this: when you want to introduce a random effect into a model, okay, you could make intercept random, you could make slope random, and you could make the two of them to be random. Okay, of course, what we're trying to do right here, we're trying to make our doctor to be random. Okay, now this is a code in R. Okay, if you want to have access to the data, okay, so that is a code in R, and this particular data was actually from the University of California in Los Angeles. Okay, now I'm actually going to copy that into R right now because I'm actually going to show you how that is actually going to run. Like I said, that is a code. Okay, so this is a code to have access to the data. Now I'm actually going to copy that right now. Give me 1 second. So I'm actually going to copy that. Okay, so I'm going to copy that right now, and I'm actually going to copy that into my heart. And don't forget the other time I said um, you are actually going to load some packages like boot, like parallel, like ggplot, and so on like that that I show you. Okay, now my R interface is loading right now, as you can see. That's my R interface. I'm actually going to paste the data now. Okay, and I'm actually it's loading right now. Then you're going to have access to the data. Okay, like I said, this particular data set is actually from the University of California in Los Angeles, the UCLA. Okay, so that is actually loading right now. Okay, so the data is already loaded. Okay, I'm actually going to attach the data right now. Okay, I'm actually going to attach the data. Okay, I think I named that HDP, right? Okay, now I'm going to click on that. Now I've attached the data. Of course, you can actually see what I have in the data, okay? We have the age, the BMI, the cancer state, the CO2, and so on like that, okay? And another way, if you actually write names, okay, names, you're going to have access to the variables in the data, okay? And if I actually write HDP now, you're going to see a lot of data, okay? Now, can you see that now? There's going to be a lot of that. It's not going to be all of them that's going to show because there are so many. Okay. Now, can you see the data now? Okay, so that is the data that I'm actually using. Okay. Now, I'm actually going to go back into the lecture material right now. Now, you've already seen the data now. Okay. And the next thing that I'm actually want to do now then is to go to the next stage of the analysis. Okay, now you can actually you saw the data now, and you know what, I can do something to actually know the summary of this data. Okay, I think it's HDP, right? Okay, so I want to know the summary. It's loading right now. Of course, you can see the summary, right? The tumor size. You can see the CO2, the pain, the wound, the morbidity, and so the number of tumors, and so on like that. Okay, the number of tumors go from minimum 0 to 9. Okay, that is in that's the number of tumor. Okay, and this is the remission, and so on like that. The age. Of course, you can see all of that. Okay, so this is the summary of that particular data. Okay, so I'm going to stop my share right now, and I'm actually going to go into the lecture material to know what is going to be the next line of action. Now, take a look at that right now. So I'm going to, so I've already done that. Then I'm going to copy this guy now. So I'm going to copy that guy now. excuse me. So I'm gonna go into R now. Okay, give me 1 second. Then I'm gonna go into my R. Okay, now try to copy that in, or try to copy that in. Oh, okay, I think I did not copy that correctly. I'm actually gonna go back. Okay, I'm gonna go back to copy that correctly. Give me 1 second. Okay, so I think I've copied the data. Okay, the next thing I'm actually gonna do, let me see some plots. Okay, I'm actually gonna, trying to, go back to my R right now. Okay, so let me go to my R interface. Okay, so let me copy. I'm gonna copy that right now. Okay, so now what I'm having at the moment that I actually want to show you is just for you to see the diagrammatical plotting, or take a look at what I have right here, the length of stay against the cancer stage. Okay, when you talk about the length of stay, we're actually talking about, okay, the more I stayed in the hospital with its doctor, how does that, how does the cancer stage affected? Okay, now, so that is what I'm actually showcasing. Okay, that's what this particular, uh, you know, the plot is actually showcasing. Okay, now, there's something I want you to see right now, which I'm actually going to call the stage. That will show us the two more stage. Okay, now give me 1 second, and I'm actually going to copy that right now. I'm going to go to my the lecture material. Then I'm actually going to show you right now. Okay, so I'm actually going to, paste that now. Now, that is going to be the code for that. Okay, now take a look at what you're going to see. It's running right now. You're actually going to see something. Okay, it's still running. Okay, now it has run. You see that now? That has run. Okay, now I'm actually going to check for something now. I'm going to stop my share, and I'm going to give me 1 second. Okay, so what I'm trying to show you now, give me 1 second. I'm actually you're gonna see my screen now. Okay, yeah, what I copied the other time, take a look at what I copied the other time. Okay, so let me copy that again. I'm gonna copy that again for you. In fact, let me clean my screen so that, because I got a lot. Okay, so I'm gonna recopy that again. Now this is what I copied the other time. Then I'm gonna run it. It's running right now. It's running right now. Okay, so it has finished running. Okay, now after that, you're actually gonna see this. You see that now? You're actually gonna see a shape like that. Okay, give me 1 second. Okay, now like I said, the next thing that I want to do right now, okay, I actually want you to see the shape, the way it's going to be. And this is where it's actually, I'm going to show you now when it run. And this is actually what is showing. I'm going to show you what is showing. Look at that after running. With this, you'll be able to monitor the stage that I'm talking about. Take a look at that. Okay. This is what they do in the hospital, when they have a scan, they are actually trying to, monitor the stage of the development. Okay. That is that. Okay. So I'm going to go back into, uh, uh, I'm going to go back into the lecture material right now. So like I said, this is a lecture material right now, and this is what I just copy. Okay. That give me that, that shape. Okay. It's GG plot of HDP. Okay, you can see that cancer stage. Okay, it's X and the length of stay. Okay, that is exactly what I just run. Okay, now the next thing that I actually want to, oh yeah, so that is what I just run. Then the next thing I'm going to do now, okay, how do we now estimate parameters? How do we estimate parameters, or in logistic regression where the random effect is incorporated? Take a look at this. Of course, don't forget the response variable is going to be remission. Okay, so that it's going to be remission or not. Okay, which is binary in nature. And of course, we have, these are the predictors. Okay, and in these predictors, take a look at that. The doctor's, effect is random. Look at that, nested. Look at that. Nested in one means, we're having a random intercept. Okay, nested in one means is we're having a random intercept. I told you the other time, you know, um, uh, when you are introducing a random effect into a model, it could be what you are introducing, maybe random intercept, it could be random slope or both. But here, I'm actually, we're introducing the random effect here is for the random intercept. That's why you see the idea is like the doctor being nested, okay, in the, in the random, in the intercept. Take a look at that. So I'm actually going to copy that right now. Okay, I'm going to copy that with a summary, and I'm actually going to go into my R. I'm going to go into the R interface right now. Oh, give me 1 second. I think I'm actually going to do that. Okay. Now, this is my R interface. I'm trying to share that with you. Yep. So this is my R interface. Then I'm actually going to copy that code now. Okay, copying the code now. So copying the code now, take a look at that. It's running. Okay, it could take a while. Okay, but it's not going to take forever to run. Okay, it's taking a while because that contains a serious code. There's a lot of code right here. Okay, so we're going to wait until it runs. Okay, we're going to see the results right away. Like I said, while we are waiting for the results, we are incorporating a random effects model into logistic regression model. And the random effect that we're actually introducing now is just doctors, okay, and being nested in the intercept. So, which is more or less like the random intercept, okay? So, like I said, when you have a logistic regression model and you actually want to introduce a random effect just because of the fact that maybe you have repeated measures or you have due to hierarchical nature of the data, of course you need to incorporate a random effect. Okay, and of course the random effect could be random intercept or random slope or random intercept and slope. But the one I'm actually using here is the random intercept. And of course, what I'm randomizing here is just the DID, which is doctor. I'm trying, that is what I'm actually randomizing. So, like I said, it's running. It's going to take a while, okay, but it's not going to take forever. So we're going to wait until the result comes out. So, like I said, what we're trying to investigate right here is just the effect of patient factors and doctor factors on the remission of cancer, on whether there's going to be a remission or not. Okay, and of course, there's going to be remission or not. Of course, we're trying to say the response variable is kind of categorical, in nature. Okay, so like I said, it's still running, and we're waiting for that. Okay, it's still running. So it's just going to take a while to run, but it's not going to take forever, just like what I said. So I think it's still running. Okay, so it's giving out results right now. Okay, so the very thing I can see on this result, I think I can see the AIC, the BIC, the log likelihood, the deviance, and so on like that. And here, okay, so did I use M to do that? Oh, okay, what I'm going to do, I'm not going to use summary for M. I'm going to use just M, and I'm going to click on it and take a look at what I have. Of course, these are the estimates of the parameters. Okay, so what I have here as the estimate of parameters. And of course, I can do the summary. I think if I want to do the summary, oh, there's something that's, highly sensitive. I'm supposed to use a lowercase. Okay, when I click on that, okay, this is the result. You can see that now. Okay, can you see that now? That is the result that is actually going to come out. Take a look at that. That is the result. I'm going to do that again, for you to really understand what I just talked about. Give me 1 second. I'm going to clean that. And what I'm actually going to do, I think I'm actually going to be posting that one by one, okay? I don't want it to take forever, okay? Okay, so let me first copy that. I'm going to copy it one by one. Okay, give me 1 second. I'm actually going to, okay, so that is going to be my R interface right now. And I'm actually going to copy that. Then I'm going to run it. Okay, so it's running. Now I just want to do that one by one, okay? One at a time. Okay, so this is the code. Okay, you can see that is the code because I want it to run. I want it to run perfectly. Okay, so it's running right now. Okay, so it's running. So I'm going to wait until it runs successfully. Okay, take a look at that. Okay, where I'm trying to look at the effect of the doctor's variable and the patient variable on the possibility of the remission of cancer. Okay, we are not going to put into consideration the patient variable alone. You got to put into consideration the doctor variable as well. And of course, the doctor variable that we're talking about right now is the experience. And the experience of a doctor matters a lot in successfully treating our patients. Okay, so it's running right now. We're going to wait. And while it is running, I also quickly want to tell you the random effect we're introducing is a random effect. We're making Intercept to be random. Initially, in the conventional logistic regression model, the intercept was not random. Intercept was fixed. Okay? And of course, situation where all predictors equal to 0. Of course, the y-intercept, okay, the y-intercept is actually going to be that intercept. Okay? That's a situation where all predictors are all equal to 0. Okay? But right now, in order to be able to withstand the hierarchical data structure, of course, we got to incorporate the random effect into this model. And that's exactly what we're doing. It is not only random, it is not, you can also try that, when what I'm running right now, I'm actually making intercept to be random. Of course, when you want to do yours, you could try slope. You can make slope to be random, and you can make the combination of that to be random. And how are you able to improve the quality of your model? Okay, So we're still waiting. It's running. We're gonna wait on it to run. If this were to be conventional logistical regression model, of course, you know, the code will run faster. Okay, so like I said, if you are running it, don't be panic, and of course, uh, you're gonna have your result. Now it has run. Okay, now what I'm gonna do, I'm actually gonna do summary into M. Gonna use M to save that, right? Then I'm gonna click on that, and this is the result that I have. Okay, now take a look at that. I got the you know, the result is going to be into way. Take a look at that. You're going to have random effect. Don't forget, in my random effects, of course, the doctors, okay, the you know, take a look at that, the standard deviation of that, then the number of observation 8,525, then the groups, okay, is 407. So which we are talking about probably which is the one we're making at random. Okay, then we're going to have the fixed effects result as well. Take a look at that. Look at the predictors, you know, the IF, the ISC, the CRP, and the cancer stage. Okay, and of course, you don't expect the cancer stage 1 to appear, because the cancer stage 1 will be used as a point of reference in a situation whereby you have levels of categorical. I mean, you have you know, a categorical predictors, and you have 4 levels. Of course, you're going to have, you know, 3 will be the 3 levels will be the one I will show. Okay, so which means the level 1 is being used as a point of reference, and of course, this is a correlation, okay, of the fixed effects. Okay, that is a correlation of the fixed effects. Okay, so and another thing I want to do right now, is there a way we can have access to the interval estimation of the estimate? Okay, we want to have access to the standard error. Of course, we have the standard error of the estimate, and we also have the interval estimation of the estimate, among other stuff. Of course, I'm going to do that right away. Okay, I'm going to stop my share right now, and I'm actually going to go into lecture material. Now, in going into lecture material right now, I wanted to, you know, this is what we just run. That is the code. Okay, so the next thing I'm actually going to do is to go into the next slide. Now take a look at the next slide. If I want to get the standard error and the confidence interval of the estimate, of course, this is the code. So I'm going to copy that right now. So I'm going to copy that right now. And of course, 1.96 means I'm doing that at 95% confidence. Okay, so I'm going to copy that into my R right now. Give me 1 second. Okay, so like I said, I'm going to share my R interface right now. And I'm going to copy that. Okay, so I've succeeded in copying that. So what is my XE? Okay, so take a look at that. Uh, that is my XE. So that is gonna be the standard error. Okay, the standard error of the estimate. Okay, if you want to get the standard error of the estimate, and that's exactly what you're gonna have. Okay, so if that is the case, um, the next thing I'm actually gonna do. Give me 1 second. So I'm actually want to write the confidence interval right now. Give me 1 second. I'm gonna copy that. Then I'm gonna, you know, okay. Now I'm gonna go back into my R interface. Okay, so that's my interface. That's my R interface. Then I'm actually gonna. Okay, so when I click on that, now take a look at what I have right now. Now, if you take a look at this, of course, I have the estimate of the parameters in the logistic regression model. And of course, I have, you know, the confidence interval, the lower bound and the upper bound. So at 95%, okay? Now, the next thing I want to do, you know, in the logistic regression model, we're actually interested in the odd ratio, okay? We're interested in the log of odd ratio, okay? And the log of odd ratio is going to be the exponent. You're going to do you're going to exponentiate the estimate, okay? So how do we exponentiate the estimate? Of course, what I'm going to do right now, I'm actually going to write expo tab, okay? Give me 1 second. I'm actually going to write expo tab. So why am I writing the expo tab? Okay, I'm going to write expo tab because if you take a look in my code, okay, I use a tab. Look at that, tab bind of that, right? Okay, so expo tab, then that will give you, there's a difference between this guy and this guy. This is what we're going to pay attention to. This is the log of odd ratio, which is the exponentiating the tab. Okay, you can see that now, and that's exactly what we have. Okay, so and that is what I wanted to say. Okay, I'm gonna go back into the lecture material right now. Okay, so this is gonna be the end of that. Like what I said today in my lecture, of course, I actually walk you through how you can actually incorporate a random effect into logistic regression model. Okay, and of course, the takeaway from today is that if you really want to analyze data set, it's better you need to understand your data set, okay? When you understand your data set, you'll be able to know what is the appropriate statistical model we're actually going to use. You know, it's not as if that in the world, that it's not as if our models are failing us. Our models are not failing us, but the issue remains that we don't pay more attention to this model, okay? But we don't pay more attention in the sense that we use a wrong model on, on data, okay? And that is the reason why, the data, the model and the data, they have to be in the same stage. I mean, in the same state, okay? And before you can actually get the real information that you need. Like I said, uh, the physical world exists independent of human knowledge, okay? The physical world exists independent of human knowledge, and for us to be able to understand our world, okay, for us to understand the business world, the medical world, educational world, political world, economic world, whatever world, of course, we need information, okay? And you know what? To be able to get information, we need to collect data set, right? And when collecting data set, information are not readily available. You got to make use of model. Well, okay, we need to use model. We need to confront our data with model. But the fact remains, are we actually using the right model? And that is the reason why we need to ensure that we're using the right model. That is the only thing we can do to get things right. If we're not paying attention to that, we're not going to get it right. We're going to be a wasted effort at the end of the day. So the takeaway today is just that, okay, if you're trying to look at the effects of some predictors, okay, on a categorical response, and in such a way that, the unit of measurement are actually nested, of course, nested in such a way that you're going to have what I call a hierarchical structure, then you cannot use the conventional logistic regression model that have only fixed effects, okay? So you got to incorporate the random effect into your model, okay? And the one you are actually, work on today is to work on the data where we're trying to look at the effect of, factors associated with the patient and the doctors on, on whether, there's going to be a remission case. And, remission, so that you have it, is that there's going to be a remission or not, which is categorical in nature. And because you are also putting into consideration the doctors, because don't forget, the patient are going to be nested in doctors, and that leads to a hierarchical structure. And that is the reason why a random model, a random effect need to be introduced, because that will violate the assumptions of independence. And I told you the reason why it's going to violate assumptions of independence, because of the fact that some patients that are nested in a particular doctor, they are likely going to have their responses are no longer going to be independent. A situation whereby you got a repeated response, where you interview some people over time, okay, more than one time. Of course, you don't expect their response to be independence anymore. There's going to be a violation of independent assumption, and that is the reason why you got to use you got to introduce a random effect into the model. Okay, and which is exactly what we have done. Okay, and like I said, the random effect that was introduced today is for the intercept. You could have a situation whereby you could have a random random slope effect, or the combination of the two. Okay, in my next lecture, of course, I'm actually going to focus on the random effect or mix effect in a Poisson regression model. Okay, that's actually what we're going to do next. So I want to thank everyone who have really attended my lecture today. And I hope you guys and those who will be watching the video, I hope you guys are going to enjoy it. And in case you actually want to have you want to ask question, you need clarification, of course you can actually reach out to me, and then through my email, or my phone number that is actually on the course canvas, and I'm actually going to address your issue. Okay, until next time that I'm actually going to come your way with another exciting topic in statistics, please make sure you stay safe and do have a good day.